Hey everyone, welcome back to the channel, and today we're diving into the world of Android development by exploring two foundational software architecture patterns: MVC or Model View Controller and MVVM or Model-View-ViewModel. These patterns are critical for developers who want to create modular, scalable, and testable applications. Let's break them down step by step and examine their component differences and why you might choose one over the other. What is MVC? First, let's talk about the Model View Controller MVC pattern. It is one of the oldest architecture patterns and has been widely adopted in various frameworks and applications. MVC divides your application into three distinct components, each with its own responsibilities. Model. The model is the backbone of your application. It is where your data lives. It manages application logic, handles communication with the database, and fetches data from APIs. Importantly, the model has no idea about the user interface. It focuses solely on the data. For example, in an app, if you're retrieving a list of products, the model is responsible for fetching and structuring that data. The view is all about the user's interface, or UI. It displays the data provided by the model and allows user interaction. Think of it as what the user sees on their screen: the buttons they click, the forms they will fill out, or the animations they watch. The view's job is simply to display data and capture user inputs without performing any business logic. The controller, which acts as the mediator, the controller connects the view and the module. It receives user input from the view, processes it, and updates the model accordingly. Then it retrieves data from the model and sends it back to the view for displays. For instance, when a user clicks submit on a form, the controller processes the input, updates the model, and refreshes the UI with the new data. While MVC is effective, it does have some drawbacks. The tight coupling between layers can make changes challenging, especially in larger applications. The controller often becomes a bottleneck because it handles so many tasks. Additionally, MVC has higher dependency on Android APIs, making it harder to unit test or reuse components in other parts of the application. Here's just a chart of what the MVC kind of pattern looks like so you can get a better idea based off my explanation. Now let's move on to the Model-View-ViewModel, or MVVM, a more modern architecture that addresses some of the MVC's shortcomings. MVVM separates the application into three distinct layers like the MVC, but the responsibilities are distributed differently. The model, which is similar to the MVC, the model in MVVM is responsible for data management. It abstracts the data sources, whether that's a database, a network, or a local cache. It provides the core business logic for applications. The model and the view model work closely to fetch and update data. The view layer handles the user interface just like the MVC. However, there is a significant difference. The view doesn't directly interact with the model. Instead, it observes the view model for any updates. The view's primary job is to display the data and notify the view model of user interaction. It remains free of business logic, making it much clearer and easier to maintain. The view model is the star of the architecture. It acts as a bridge between the model and the view. The view model exposes data streams that the view can observe, often through tools like live data or stateflow in Kotlin. It handles the application logic and prepares data for the UI, but it doesn't know anything about the view itself. This separation makes the view model highly testable, as you can simulate various scenarios without depending on the view. Before we take a view on the key differences between MVC and MVVM, here's another chart that goes off of the MVVM model, just like the MVC, so you can get a picture of what I just described. Now let's take a moment and compare the MVC and the MVVM directly. Role of the mediator. In the MVC, the controller mediates between the view and the model. The view doesn't directly reference the controller. In MVVM, the view model acts as the mediator. The view observes the view model and has a different direct reference to it. Decoupling. MVC's tight coupling makes it harder to modify and maintain applications, especially as they grow. The MVVM promotes a clearer separation of concerns with loosely coupled components. Testability. Testing the MVC can be challenging because its reliance on Android APIs and tightly coupled logic. MVVM separation of the view model makes unit testing much easier, as you can test data, transformation, and business logic without involving the UI. Dependency on Android APIs. MVC heavily depends on Android APIs when it can limit portability. MVVM reduces or eliminates this dependency, making it more versatile and robust. Scalability. In MVC, the controller can become a bottleneck as the application grows. MVVM's modular design makes it easier to scale and extend the application with new features. Complexity. While MVC is simpler to implement, it struggles with larger, more complex applications. MVVM introduces some complexity, especially with the data binding, but it pays off with cleaner code and easier maintenance. Here's why MVVM is becoming a preferred architecture in the Android world development. Improved separation concerns. MVVM ensures that the view model and model each have distinct responsibilities. This makes the code base easier to understand, maintain, and debug. Better testability. With the view model handling logic, you can test your application's functionality without relying on the UI. This is particularly useful for ensuring app behaves as expected. Greater flexibility. The view model allows you to reuse the same data and logic across multiple views. This is ideal for applications with varying layouts or multiple user interfaces. Collaborative development. By decoupling the view model and the model, multiple developers can work on different parts of the application simultaneously without stepping on each other's toes. So, when to choose MVC or MVVM? Use MVC if you're building a smaller application or working in a legacy code base where simplicity and speed of implementation are the priorities. Use MVVM for modern, larger applications that require scalability, maintainability, and robust unit testing. By understanding these patterns, you can select the one that best fits your project's needs and ensure a smoother development process. Thank you for tuning in to this in-depth explanation of MVC and MVVM. If you found this helpful, be sure to like, subscribe, and share this video. Keep coding and see you next time.